Hi everyone, welcome back to Lulumath. This video is on challenging factoring completely problems. So the background knowledge that you will need is you'll need to know how to factor completely because this video is taking it up a notch and we're going to do some more challenging examples of factoring completely questions. So if you need a refresher or you need some help with that, please make sure to check out the video at lulumath.com or on the Lulumath YouTube channel. This is the second of two challenging factoring completely videos. If you need more examples, make sure to check out the first video. All right, in our next example, we will still go down our list of questions. So our first question is there a GCF? So looking at all of my factors here, I've got a coefficient of a 3, I've got a negative 15, I've got a positive 60, and a negative 12. So yes, there is a GCF. All of these coefficients are divisible by 3. There are also variables in common with all four of my terms. All four of my terms have b's in common. So I've got b to the power of 4, b to the power of 3, b to the power of 1, and b to the power of 2. So I'm going to take out a b to the power of 1 because that's my lowest exponent. However, there are no c's in common with all four of our terms. Our first term doesn't have a c in it, so there's no c in our GCF. When I factor out a 3b from my first term here, 3 divided by 3 is 1, and b to the power of 4 divided by b is b to the power of 3 because 4 minus 1 is 3. In my second term, negative 15 divided by 3 is negative 5. B to the power of 3 divided by b is b to the power of 2. And then I have a c left over. In my third term, 60 divided by 3 is positive 20. B divided by b cancels each other out. And then c to the power of 3 divided by a single 1 is going to be c cubed here. And then lastly, when I divide negative 12 by this 3 here, I end up getting negative 4. And then b squared divided by b to the power of 1 is b. And then c squared is going to just tag along. So I've taken out my GCF. Now I want to know, is it a difference of perfect squares? Looking at my first factor, it is a monomial, so it is not a difference of perfect squares. Looking at my second factor, it's 4 terms, so it is also not a difference of perfect squares because I need 2 terms for this to work for us. So my third question is it a factorable trinomial? Well, neither one of my factors is a trinomial, so the answer to that is no. So let's see if I can factor by grouping. In my expression right here, I have 4 terms, so it looks like it is possible. So I will take my first 2 terms and group them together. So I've got b to the power of 3 minus 5b squared c. Then I will take my second 2 terms and factor those together. So plus 20c cubed minus 4b c squared. Don't forget to copy down your GCF. Well, looking at my first group, I can see that they have a b squared in common, so I will factor that out. Well, when I factor out a b squared from b to the power of 3, I have a b left over. And when I factor out a b squared from negative 5b squared c, I'll have a negative 5. The b squareds cancel, and then I have a c left over. Now, in my second group right here, I can see that there is a 4 in common, and there are also c squareds in common. So when I factor it out of my first term, I have a positive 5c, and then when I factor it out of my second term here, I will end up getting a negative b. Don't forget to have a second set of brackets here because this 3b is being multiplied by all of this entire factor by grouping expression here. Now here's where things get tricky because although it looks very close to each other, our brackets here are not exactly identical. If you see here, we have a positive b, but here we have a negative b. And if you see here, we have a negative 5c, but here we have a positive 5c. So if I were to just switch these signs, then this will work for us. So what I'm going to do is I will factor out a negative. So instead of positive 4c squared here, I will have a negative 4c squared, which will make this 5c a negative 5c and this negative b a positive b. So then I will copy the rest of what I have down here. And don't forget your GCF in front. Now, if you see here, this b minus 5c is exactly the same as this negative 5c plus b. It's just written in a slightly different order. So I'm going to factor out this b minus 5c, and then what's left over is this b squared here, and then I have a minus 4c squared left over right here. Don't forget to copy down this 3b. And then we've gotten to a point where we can ask ourselves, is it completely factored? But before we do that, I just want to make one quick note. Instead of writing this 20c cubed minus 4bc squared as follows, I could have switched these two terms with each other, making this group here say minus 4bc squared plus 20c cubed instead. And then I could completely skip over this step right here, and I can factor out a negative 4 from both terms here, as well as a c squared. And when I factor that out, this would end up becoming negative 4bc squared divided by negative 4c squared. The negative 4's cancel out, the c squareds cancel out, and then I'd have a b left over. And then 20 divided by negative 4 is negative 5, and c cubed divided by c squared is c. And then if you look here, we would end up getting the exact same thing when I'm factoring by grouping. Regardless of how you do it, when you get to a point that looks like this, you have to recognize that you're very close to be able to factor by grouping, but it's not quite right, and we have to play around with it a little bit for us to get to this point right here. Now I want to ask myself, is it completely factored? Well, I have 3 separate factors. So for each one of these factors, I'm going to ask myself, is there a GCF? Is there anything in common with the 3b here? It's a single term, so there's nothing in common. This b minus 5c, there's nothing in common with it. And this b squared minus 4c squared has nothing in common either. Then I want to ask myself, is it a difference of perfect squares? Well, this 3b here is not, because it's a single term. This b minus 5c is not, because although it has a binomial and subtraction, b is not a perfect square, 5 and c are not perfect squares. However, in this expression, this b squared minus 4c squared, I can say yes, it is a difference of perfect squares because A, it's a binomial, B, there is subtraction, and C, we have some perfect squares. So I'm going to take this expression and break it up. So I will take the square root of this b squared, which is b, and I'll take the square root of this 4c squared, which is 2c, and I will have a plus sign and a minus sign. Don't forget, we're not changing our expression, so we have to copy down this 3b, and we also have to copy down this b minus 5c. Now we have 4 different factors. So we're going to start from the beginning. We've got 3b, b minus 5c, b plus 2c, and b minus 2c. So is there a GCF? Well, we figured out there's no GCF in our first 2 factors. Looking at our third factor, there's nothing in common. And looking at our fourth factor, there's nothing in common. So there is no GCF. Next question, is there a difference of perfect squares? Well, we figured out 3b is not a difference of perfect squares. b minus 5c is not a difference of perfect squares. So let's talk about b plus 2c. It is a binomial, but there's addition, so it is not a difference of perfect squares. This is a binomial of subtraction, but b is not a perfect square and 2c is not a perfect square. So it's not a difference of perfect squares. So now let's see, are there any factorable trinomials? Well, my first term is not a trinomial. Well, my first factor is not a trinomial, neither is my second factor, neither is my third factor, neither is my fourth factor, so no, it is not a factorable trinomial. Lastly, can I factor by grouping? And none of my factors here has a minimum of 4 terms, therefore I cannot factor by grouping. So since the answer to all of my questions for each one of my factors is no, then I can for sure say yes, my answer is completely factored, and this is my final answer right here. All right, in our last example, we have the quantity x squared minus 3x squared minus 14 multiplied by the quantity x squared minus 3x plus 40. Now, before we approach this question, I just want to point out that we technically have 1, 2, 3 separate terms that we're dealing with at this point in time for our factoring. So first we'll ask ourselves, is there a GCF? And there is no GCF in common with this x squared minus 3x quantity squared minus 14 times the quantity x squared minus 3x and 40. So our next question is it a difference of perfect squares? Well, again, we have 1, 2, 3 terms, so it is not a difference of perfect squares because we need a binomial to have a difference of perfect squares. Now, is it a factorable trinomial? Well, we do have 3 separate terms, so we're going to try to see if we can factor this trinomial. But before we do that, I want to do a little bit of substitution here to make our factoring a little bit easier. It will also help me to see that this is a factorable trinomial. So I'm going to let u equal x squared minus 3x. So this whole piece right here, I'm going to let that be u. So since all of x squared minus 3x is being squared, we can now say u squared. And then since this is minus 14 multiplied by this x squared minus 3x, I can say minus 14u. And then there's just a plus 40. Now it's a lot easier to factor this. This first term multiplied by this first term will give us this u squared. So we can do u times u. And then this last term multiplied by this last term will give us this 40. So let's make a list of factors of 40. We can do 1 and 40. We can do 2 and 20. We can't do 3. We can do 4 and 10. And then we can also do 5 and 8. And that is our complete list of factors. I'm looking to get a negative 14, which I can get from this 4 and this 10. So I will put a 4 here and a 10 here, and it will only work if I have a negative 4 and a negative 10, because that will add up together to give me negative 14, but multiply together to give me this positive 40. Now I'm going to substitute x squared minus 3x back in for u. So instead of this u right here, I'm going to replace it with this x squared minus 3x. But we still have this minus 4 right here. And then instead of this u here, I'm going to replace it again with this x squared minus 3x. But we still have this minus 10 right here. And now I have two sets of trinomials that I can factor. So in my first trinomial here, I will factor this as two binomials multiplied together. And I know the first multiplied by the first will give us this x squared here. So I will use x times x. And I know the last multiplied by the last will give us this negative 4 here. So factors of 4 are 1 and 4 or 2 and 2, but I'm trying to get a negative 3. So I will use 1 and 4. And this will work for me if I have a positive 1 and a negative 4. Now I'll take a look at my second binomial and do the same thing. So I know the first multiplied by the first will give us this x squared. So I will use x times x. And I know that the last multiplied by the last will give us this negative 10. So I'm going to think of factors of 10. Well, I can do 1 and 10, or I can do 2 and 5, but I know that I'm trying to get this negative 3 here. So I will use a 5 and a 2, and I can get a negative 3 from a negative 5 and a positive 2, which multiply together to give me this negative 10. Now I'm going to see, can I factor by grouping? So looking at each one of my factors here, each factor has two terms. Each factor is a binomial, which means that I cannot factor by grouping. So that answer is a no. Lastly, I want to know, is it completely factored? So for each one of my factors, I'm just going to go down my list really quickly. And if everything is good to go, then we're done. So is there a GCF? None of my factors have anything in common. Is it a difference of perfect squares? Although they're all binomials, we only have two factors that have subtraction in them. However, x and 5 are not perfect squares, which means we don't have perfect squares here. Do we have factorable trinomials? Well, they're all binomials, so no, it's not possible. We've already established that we can't factor by grouping, so the answer to this question is yes, it is completely factored, making this our final answer. Thank you for watching. If you have any questions, please let me know in the comments below or at lulumath.com, where you can also find blank or completed notes for this video. If you found this to be useful, please don't forget to subscribe and share with others. Thank you. We'll see you next time.